Hi everyone, and welcome to the Choosing a Data Collection Strategy video lecture. Let's get started. There are several different types of data collection strategies that are commonly used in criminal justice research. The ones I'm going to cover in this lecture video are experiments and non-experimental research designs, more specifically correlational analysis, qualitative research, and case studies. The choice of data collection strategy is driven primarily by the purpose of the study, followed by the time and budget constraints of the researcher. I want to back up a minute to refresh your memory from a previous lecture, How to Start a Research Study. This video lecture laid out 4 different purposes of research. Exploratory research is done with the intention of becoming familiar with a new subject or topic. Descriptive research is done to describe a situation, event, or a person in depth. Explanatory research is done to identify a cause and effect relationship, and evaluation research asks questions about the implementation and outcomes of a program or policy. Some of the data collection strategies just mentioned work better or worse for each of these research purposes, so it's important to have a good understanding of your research purpose before you go about selecting a data collection strategy. Experiments are one of the ideal research designs for explanatory research. What an experiment allows you to do is manipulate the independent variable so as to see the change in the dependent variable. Also important in an experiment is making sure that all the other variables that may affect the dependent variable are held constant as control variables. Here's the quintessential science experiment that you might have seen in high school. The goal of the study is to look at the cause and effect of some stimuli on plant growth. In this case, the independent variable is the light color. So the study is trying to see what changing the light color does to the plant growth. In order to ensure an unbiased comparison, the other variables that would affect plant growth, including the type and frequency of watering, the soil composition, the temperature, and the time in and out of the light, is all kept the same for both plants. This way, the difference in height can be reliably acknowledged as being caused by the independent variable and only the independent variable. What this looks like in a criminal justice setting is similar to this. Our sample is split into 2 groups, an experimental group and a control group. The researcher measures the dependent variable during what is called the pretest. Then, the independent variable is introduced to the experimental group, while the control group continues as usual. Then at some point afterward, the dependent variable is measured again for both the experimental and control groups to observe the differences. To put more concrete descriptions here, here's the same design testing to see if there's a cause and effect relationship between watching a movie with popcorn and feelings of happiness. So 2 groups take a survey asking, how are you feeling today? And here's how they started. Then the experimental group is shown a movie and they're given popcorn. The control group isn't given anything. Then both groups are asked to take the survey again and identify how they're feeling. If the experimental group feels happier now than they did at the pretest, and the control group feels the same, then we can conclude that the movie and the popcorn improved their happiness. There are several different types of experimental designs, including natural experiments, laboratory experiments, and quasi-experiments. Your readings this week touches on those topics, so I want to highlight them, but I'll save specific details on each type of experimental design for our experiments module. What about if you're not doing a cause and effect analysis? Sometimes we're looking to describe a situation more in depth, or we're interested in exploring a new topic that we don't know enough about to hypothesize a cause and effect relationship yet. For these situations, we typically turn to non-experimental research. There's a wide range of non-experimental designs, so this category is pretty broad. But overall, this type of research design can be helpful when you only have one variable of interest, when you're trying to describe the experiments of a particular group, and or when your independent variable cannot be manipulated by the researcher for ethical or logistic purposes. Correlation analysis is one type of non-experimental research design. Here the goal is to analyze how the 2 variables change in relation to one another. On these graphs, variable A is represented by the x-axis, or the horizontal line going across. As the values of variable A get larger, the data points move further to the right side of the graph. Variable B is represented as the y-axis, or the vertical line going up the graph. As the values of variable B get larger, the data points move further up towards the top of the graph. When there's a positive correlation between A and B, it means that as variable A gets bigger, so does variable B. A negative correlation means that as variable A gets bigger, variable B gets smaller. And no correlation means there's no relationship. Variable A and B values occur independent of one another. What makes this design different from an experimental design is that there is no attempt by the researcher to control other potentially important variables. We're simply looking at variable A and variable B and looking to see whether there's a relationship or not. The lack of control variables is one of the reasons for a slogan that you may have heard before: correlation, not causation. Even if A and B are correlated to one another, it does not automatically mean that there's an actual cause and effect relationship. It could be that another variable that you're not measuring is affecting both variables. We'll talk about causation more in depth when we explore experimental design, but for now I just want you to understand the basic concept of correlational analysis. Qualitative research is another type of non-experimental research. While there are ways to quantify qualitative data, typically qualitative data is sensory and descriptive in nature, and as such is not able to be analyzed statistically for comparison. We'll talk about qualitative more in depth during our qualitative research module, but this is a really common method used for exploratory and descriptive research. The last type of non-experimental research I want to touch on are case studies. These are in-depth analyses of a particular person, group, or event. Case studies are usually comprehensively descriptive, and they may provide explanations of cause and effect for that particular situation. However, the goal of a case study is not to generalize. It's to understand that particular person, group, or event in the most detail possible. Since that one person, group, or event does not represent every person or every group or every event, then we cannot generalize from one case study to everyone. Here's an example illustrating how a case study differs from a more generalizable explanatory research study. In the case study, the goal is to look at one specific airplane crash and identify all the factors that went into causing the airplane to fail. This includes pilot error, older plane model, TSA error, an unexpected weather anomaly, and a failing engine. All of these causes work together to cause the plane to crash. While this is incredibly helpful for us to learn why this particular plane crashed, this does not mean that every plane that crashes due to a mix of these solutions or situations. To do that, we would need a broader, more generalized sample of plane crashes. So maybe we take the last 5 airplane crashes that occurred on that specific plane model. Then we would analyze the potential pilot error in each crash, after which we could make a more robust prediction of whether or not pilot error contributes to plane crashes overall. All right, well, that concludes this lecture video. Thanks for watching, everyone.